Hello and welcome to Lesson 4 Graphical Analysis. In this video, we're going to be doing Example 1, Part A. In Part A, the question asks us to find the average velocity from 0.25 seconds to 5 seconds on the given graph of position versus time. Now, just ahead of this question, or this example problem, the book shows us how to find average velocity based off of a position time graph. The way to find average velocity is we want to find the slope of the secant line between our 2 points. Now, we're going to jump into this right away. First thing that I want to break down is make sure you notice when we're talking slope of a line, we talk about rise over run. Rise over run, in this case, would be rise is meters. Run is our x coordinates. That's going to be in the unit seconds. So you can see right away that our units are going to work out to meters per second for slope. All right, so let's jump into this. First thing we want to do in this is we want to identify our points on the graph. I didn't put any numbers on this graph just because I hand drew it and it wouldn't be very close to scale. So instead, I'm just going to plot these points similar to where they would be on your graph. So I'm going to draw my first point somewhere in this region. All right. And it's at 0.25 seconds, and time is along the x-axis. So I'm going to label that point for you. 0.25. And if you follow it up the y, to get our y coordinate of this point, it's going to be, what did I get? I got approximately 11 meters. So this point is going to be 0.25, 11. If we follow this up, we want to find where our 5-second point is. The 5-second point on this graph is right at the max here. And so the coordinates on this are going to be 5 and about 50 is what I got. Now, if you read the graph slightly differently, you could have a very slightly different answer, but this is going to be approximately what we're at. All right. Now, if you want, you can draw the secant line on for clarity. I am, but it's not totally necessary. I'm going to use my ruler tool here, and I'm going to line this up. 1 point there, 1 point there. I'm going to draw this through here. In fact, this can extend past it a little bit as well. Okay, this is what we're finding the slope of, is this line right here. Great. Well, we have a line, and we have 4 points. Well, 2 points with 4 values, 2 x's and 2 y's. We know how to find slope, hopefully by now. So let's work this out. We know that slope is equal to rise over run. We've said that already. Well, to find slope and the rise, we're going to use this formula, y2 minus y1 divided by x2 minus x1. Great. All we have to do now is plug some math values in here. So this is going to be our y is going to be, y2 is 50 in this case. 50 minus 11. Notice our y values, 50 and 11. Divided by 5 minus 0.25. Awesome. We can essentially plug that into our calculator, and what we get if we solve for both of these, well, I'll do the intermediate step. It's 39 divided by 4.75, and if we take it all the way to the end, it's going to equal 8.2 meters per second. I didn't actually put all my sig figs in, so if you want to catch me on that, that's fair. But what do we have? This is 0.25. This was 5.00. So this is 3 sig figs, but the 0.25 is only 2 sig figs. This 0 doesn't count. So this is our final answer, 8.2 meters per second. It's the slope of the secant line to find average velocity. And that's all for this lesson.